Assalamu alaikum everyone. This is Dr. Zaktofin from Teacher Education College of Setif, Department of Science. This video will explain the different phenomena and principles related to spectral lines as part of the course Atomic Physics and Spectroscopy. As you can see in this mind map, spectral line is the second chapter of the second part of this course. Concerning learning objectives, our main objectives are to understand the origin of spectral line from atomic and molecular transition and how this line reflects changes in energy states. Also, to differentiate between emission, absorption, Stark and Zeeman spectral line and explain their significance and various contexts. Also, to analyze the key characteristics of spectral lines and to explore the effect of electric and magnetic field on these spectral lines. And finally, to apply knowledge of these spectral lines to various scientific fields such as physics and chemistry. This video will contain an introduction, atomic and molecular transitions, type of spectral lines, characteristics of spectral lines, and also application of spectral lines and conclusion, and we will end with an exercise. Introduction. First of all, we need to know what is spectroscopy. Well, spectroscopy is a branch of science concerned with the investigation of analysis of the interaction between matter and electromagnetic radiation, or we can call it light. It involves the study of how different types of materials interact with various wavelengths of light, ranging from radio waves to gamma rays. By analyzing the absorption, emission, or scattering of light by atoms, molecules, or solids, spectroscopy provides valuable information about composition, structure, or properties of substance. In this figure, we can see clearly the different wavelengths and the frequencies and the approximate scale of each wavelength. Now, what is spectral line? Spectral lines in spectroscopy are fundamental components of the electromagnetic spectrum that arises from the interaction between matter and electromagnetic radiation. They serve as a crucial indicator of the energy state and transition within atoms, molecules, ions, or other systems, providing rich information about their composition, structure, and dynamics. Understanding spectral line is essential in various fields, including physics, chemistry, astronomy, and material science. Atomic and molecular transition. Spectral line originates from the transition between quantized energy levels in atom or molecules, as we can see in this figure. In atoms, these transitions typically involve electrons moving between different orbitals or energy levels. Each transition corresponds to a specific change in energy, resulting in the emission or absorption of electromagnetic radiation. Similarly, in molecules, transition can occur between different vibrational, rotational, or electronic states, leading to the formation of distinct spectral lines. Type of spectral lines. Now that we know what are spectral lines and their origin, we need to know the different types of spectral lines, starting with emission lines. These lines appear in spectra when atoms or molecules emit photons as they transition from higher to lower energy levels. Emission lines are observed as a bright line against a dark background and are characteristic of the composition of temperature of emitting source. Example includes the hydrogen-Balmer series and the emission line observed in stellar spectra. We can also see another type, which is absorption lines. Absorption lines occur when the atoms or molecules absorb photons of specific energy, causing transition from lower to higher energy level, exactly the opposite of the emission lines. These lines appear as dark feature against a continuous or bright background spectrum. Absorption lines provide valuable information about chemical composition and physical condition of the absorption medium. They are commonly observed in stellar spectra where they reveal the presence of elements and molecules in the outer layer of stars. We can also see other types of spectral lines, such as Zeeman and Stark lines. Stark and Zeeman lines effects arising from the interaction of atoms or molecules with electric and magnetic fields, respectively, can cause spectral lines to split into multiple compounds. These shifts in energy levels gives rise to additional spectral features known as Stark or Zeeman lines, which provide insight into the properties of the fields and the system under investigation. This table can give us different properties of the Zeeman effects and Stark effects. Characteristic of spectral line. One of the main characteristics of spectral lines are wavelength and frequencies. Each spectral line is associated with specific wavelength or frequency of electromagnetic radiation, determined by the energy difference between the initial and the final state of transition. The position of spectral line in the spectrum provides valuable information about the energy level involved and the nature of the emitting or absorbing species. Another characteristic is intensity. The intensity of spectral line reflects the relative probability of the corresponding transition occurring. Also, the width and the shape of the line is one of the main characteristics of spectral line, because a spectral line can have varying width and shapes influenced by factors such as natural line width, Doppler effect, pressure broadening, and instrument effects. These figures show two ways of showing the same spectra. On the left, there is a picture of dispersed light, and on the right are plots of intensity vs wavelength. Notice there is a pattern of spectral line in the absorption and emission. Line spectra are the same, since the gas is the same. Now, why we study those spectral lines? Of course, for their applications. Well, the analysis of the spectral line enables scientists to identify elements, isotopes, and molecules, determine their abundance, study their electronics and vibrational structure, and probe their physical and chemical properties. Also, spectroscopic techniques explore unique signature of spectral lines to investigate diverse phenomena ranging from stellar evolution and galactic dynamics to chemical reaction, atmospheric, composite, and material characteristics. In conclusion, spectral lines are an essential tool in understanding the interaction between matter and electromagnetic radiation. They provide crucial insight into the energy state of atoms and molecules, revealing detailed information about their composition, structure, and dynamics. Through the study of spectral lines, scientists can probe the fundamental properties of matter across various fields, making them indispensable in modern scientific research and applications. Now, finally, I can leave you with a simple exercise of identifying an unknown gas using emission spectra. As a scientist, you have a sample of unknown gas. In order to identify the gas, you look at the spectrum of visible light emitted from it when it's heated. This is shown in the figure. I'll show you the figure later. Also shown in the figure are the emission spectra of 5 pure gaseous elements. Which of the 5 elements in the unknown gas? Xenon, argon, oxygen, helium, or neon? Now, for this final picture, you can see on the top the unknown gas spectrum. And under it, you can see the helium, oxygen, neon, argon, and xenon spectrum. You can just identify the unknown gas. Thank you, and I hope you will enjoy this course.